Hello, and welcome to tonight's Spaceflight Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we pause our journey outward to reflect on those who first reached these heights and to understand the remarkable atmospheric realm we're floating through. Over the next 90 minutes, you will learn about the courageous pioneers who ventured into orbit before you and discover the fascinating layers of atmosphere that protect our planet. So settle into your most comfortable position, close your eyes, and prepare to float with history. Take a deep breath with me now as we begin. Inhale slowly for 4 counts. 1, 2, 3, 4. Hold gently. Exhale for 6 counts. Releasing all tension. You are floating peacefully in low Earth orbit, the same realm where hundreds of brave explorers have traveled before you. Outside your window, Earth rotates below. A view that was once impossible to imagine, now a reality thanks to those who dared to dream. We begin with the first human to see this view. On April 12, 1961, Soviet cosmonaut Yuri Gagarin launched aboard Vostok 1 from Baikonur Cosmodrome in Kazakhstan. His flight lasted only 108 minutes, a single orbit around Earth, yet it changed human history forever. Gagarin was 27 years old, a fighter pilot selected from thousands of candidates for his skill, calm demeanor, and courage. As he lifted off, he reportedly exclaimed "Poyakali," which means "let's go" in Russian. A simple phrase marking humanity's giant leap into the cosmos. Dato. Gagarin's spacecraft was automated. He had little control over its systems as engineers worried about the psychological effects of weightlessness on human cognition. The capsule rotated slowly, giving him continuous views of Earth through small portholes. He reported seeing our planet's curvature, the thin blue atmosphere, and the blackness of space beyond. Upon seeing Earth from orbit, he radioed back, "The Earth is blue. How wonderful. It is amazing." These words, spoken in awe, became one of the most famous observations in space exploration history, capturing the profound beauty of our home planet. His single orbit took him over Siberia, the Pacific Ocean, the southern tip of South America, and Africa, before re-entering Earth's atmosphere over the Soviet Union. At 7,000 meters altitude, Gagarin ejected from his capsule and parachuted separately to the ground, landing in a field near the Volga River. Local farmers witnessed his arrival, still wearing his bright orange spacesuit, unsure whether he was friend or foe. Gagarin quickly assured them he was a Soviet citizen who had just returned from space. Within hours, the world knew that humanity had entered a new era. Less than 1 month later, on May 5, 1961, astronaut Alan Shepard became the first American in space. His flight aboard Freedom 7 was suborbital, reaching an altitude of 116 miles, but not achieving orbit. Shepard's flight lasted only 15 minutes, 22 seconds, yet proved that Americans could also venture beyond the atmosphere. Unlike Gagarin's automated flight, Shepard had manual control of his spacecraft, testing systems that would be crucial for future missions. He became a national hero, helping America gain confidence in the young space program. The first American to orbit Earth was John Glenn, aboard Friendship 7, on February 20th, 1962. Glenn completed 3 orbits in 4 hours 55 minutes, proving that Americans could match Soviet achievements in orbital flight. Glenn was 40 years old at launch, older than most astronauts, making his selection controversial among some who favored younger pilots. But Glenn's experience and calm professionalism made him ideal for this high-stakes mission. During his flight, Glenn observed what he called fireflies, glowing particles outside his window that were later determined to be ice crystals illuminated by sunlight. Glenn's flight was not without tension. Mission Control received a signal suggesting his heat shield might be loose, potentially causing catastrophic failure during re-entry. Controllers decided not to tell Glenn immediately to avoid causing panic. They instructed him to retain his retro rocket package during re-entry, contrary to normal procedures, hoping it would hold the heat shield in place. Glenn followed instructions, despite not understanding why, watching flaming debris stream past his window as he plunged through the atmosphere. He landed safely, and the heat shield had been secure all along. The sensor had malfunctioned. His courage under pressure became legendary. On June 16, 1963, Valentina Tereshkova became the first woman in space, launching aboard Vostok 6. She was only 26 years old, a textile factory worker and amateur skydiver with no formal pilot training. Soviet officials selected her partially for propaganda purposes, wanting to demonstrate gender equality in their society. But Tereshkova proved herself a capable cosmonaut, completing 48 orbits over nearly 3 days, more orbits than all American astronauts combined at that time. She orbited Earth while another spacecraft, Vostok 5, with cosmonaut Valery Bykovsky, orbited simultaneously, coming within 3 miles of each other. Tereshkova faced significant challenges during her flight. She experienced nausea and physical discomfort from prolonged weightlessness. She discovered an error in the spacecraft's navigation software that would have caused her to fly away from Earth rather than return. She reported the problem to ground control, and engineers uploaded corrected commands. Despite difficulties, she remained composed, completing her mission successfully. Upon landing, she reportedly gave away her emergency rations to locals who met her. Sharing food meant for survival. Her achievement opened possibilities for women in space programs worldwide, though it would be nearly 20 years before another woman flew in space. These early pioneers ventured into a realm humans had only imagined for millennia. They passed through Earth's atmosphere, crossing invisible boundaries that separate our familiar world from the cosmic void beyond. The atmosphere they traveled through consists of distinct layers, each with unique characteristics and phenomena. Understanding these layers helps us appreciate the remarkable protective blanket surrounding our planet. As you float here in low Earth orbit, you exist within the outermost reaches of this atmospheric system, still connected to Earth, yet touching the edge of space. The atmosphere begins at Earth's surface, extending upward in layers of decreasing density. The lowest layer, the troposphere, extends from sea level to about 6 miles high at the poles and 11 miles at the equator. This is where weather occurs, where clouds form, where rain falls, and where commercial aircraft fly. The troposphere contains about 75% of the atmosphere's total mass and nearly all its water vapor. Temperature decreases with altitude in this layer, dropping about 3.5 degrees Fahrenheit for every 1,000 feet of elevation. At the top of the troposphere, temperatures reach approximately -60 degrees Fahrenheit, creating a boundary called the tropopause. Above the troposphere lies the stratosphere, extending from about 7 miles to 31 miles altitude. This layer contains the famous ozone layer, which absorbs harmful ultraviolet radiation from the sun, protecting life on Earth's surface. Unlike the troposphere, temperature increases with altitude in the stratosphere, because ozone molecules absorb solar energy, converting it to heat. At the top of the stratosphere, temperatures can reach near freezing, despite being much higher than the troposphere's summit. The stratosphere is remarkably stable, with little vertical air movement, making it ideal for long-distance balloon flights and some specialized aircraft. The boundary at its top is called the stratopause. The mesosphere extends from about 31 miles to 53 miles altitude. This is where most meteors burn up, creating the shooting stars visible from Earth's surface. Temperature decreases with altitude again in this layer, reaching the coldest temperatures found anywhere in Earth's atmosphere, approximately -130 degrees Fahrenheit at the mesopause. The air here is extremely thin, but still dense enough to cause friction with space debris. Noctilucent clouds, the highest clouds in Earth's atmosphere, form in the mesosphere, visible only during twilight, when sunlight illuminates them from below the horizon. These ethereal clouds appear silvery blue, creating delicate patterns across the polar sky. Above the mesosphere lies the thermosphere, extending from about 53 miles to between 300 and 600 miles altitude, depending on solar activity. This is where you float now, in low Earth orbit. the thermosphere's temperature increases dramatically with altitude, reaching up to 2,700 degrees Fahrenheit during periods of high solar activity. However, the air is so thin that these high temperatures would not feel hot to your skin, because there are too few molecules to transfer heat effectively. The International Space Station orbits within the thermosphere at an altitude of approximately 250 miles, completing an orbit every 90 minutes. The thermosphere is where aurora occur, those spectacular light displays visible near Earth's poles. Aurora form when charged particles from the solar wind collide with oxygen and nitrogen molecules in the upper atmosphere. These collisions excite the molecules, causing them to emit light in various colors, primarily green from oxygen at lower altitudes, and red from oxygen at higher altitudes, with occasional blue and purple from nitrogen. From orbit, astronauts see aurora from above, appearing as shimmering curtains of light draped across Earth's curved surface. The displays dance and pulse with solar wind fluctuations, creating ethereal beauty in the near vacuum of space. The outermost atmospheric layer is the exosphere, extending from about 600 miles to 10,000 miles altitude, where it gradually transitions into interplanetary space. The air here is incredibly thin. Molecules can travel hundreds of miles without colliding with other molecules. This is where satellites in high orbits circle Earth, where atmospheric drag becomes negligible, allowing them to remain in orbit for centuries without propulsion. The exosphere has no clear upper boundary, instead fading gradually into the solar wind and cosmic radiation that fill interplanetary space. Earth's magnetic field extends beyond the exosphere, creating the magnetosphere, which protects our planet from harmful solar radiation. The boundary between Earth's atmosphere and space is not precisely defined, but commonly accepted as the Kármán line at 100 kilometers or 62 miles altitude. Hungarian physicist Theodor von Kármán calculated that above this altitude, aircraft cannot generate sufficient lift from the thin air, requiring rockets for propulsion instead. This altitude became the internationally recognized boundary of space, though some organizations use different definitions. When Gagarin crossed this boundary in 1961, he became the first human to officially leave Earth's atmosphere, entering the realm where orbital mechanics rather than aerodynamics govern motion. Breathing slowly, you can appreciate that you're floating at the boundary between Earth and cosmos. The atmosphere below sustains all life, providing oxygen for respiration, nitrogen for plant growth, and a protective shield against radiation and meteor impacts. The thin blue line visible at Earth's horizon represents the totality of breathable air accumulated over billions of years. This fragile layer averages only about 60 miles thick, less than 1% of Earth's radius. Yet it makes our planet a haven for life in an otherwise hostile universe. Every breath ever taken, Every word ever spoken, every song ever sung, occurred within this narrow band. The pioneers who first reached this altitude understood they were entering a realm where human life could not naturally exist. They depended entirely on technology for survival, enclosed in metal capsules that provided air pressure, oxygen, and temperature control. Early spacecraft were primitive by modern standards, offering minimal comfort and control. Cosmonauts and astronauts accepted enormous risks, launching atop converted ballistic missiles originally designed as weapons. The courage required to strap into these experimental vehicles and ride pillars of fire into the unknown cannot be overstated. They were test pilots in the truest sense, pushing the boundaries of what was possible. On March 18, 1965, Soviet cosmonaut Alexei Leonov became the first human to perform a spacewalk, technically called extravehicular activity, or EVA. During the Voskhod 2 mission, Leonov exited his spacecraft through an inflatable airlock, spending 12 minutes, 9 seconds floating in space, tethered only by a 17-foot cable. His spacesuit ballooned in the vacuum, making movement difficult and preventing him from re-entering the airlock as planned. Leonov had to release some air from his suit, risking decompression sickness, to reduce its size enough to squeeze back inside. He barely fit through the narrow opening, entering head first rather than feet first as trained. The incident remained classified for years, but Leonov later described it as the most dangerous moment of his life. Three months later, on June 3, 1965, American astronaut Ed White became the first American to walk in space during the Gemini 4 mission. White spent 23 minutes outside his spacecraft, maneuvering with a handheld gas-powered device. He reported feeling exhilarated by the experience, reluctant to end the spacewalk when commanded to return inside. His famous words, "It's the saddest moment of my life," conveyed his emotional response to leaving the freedom of space and returning to the confined capsule. White's successful EVA proved that Americans could also perform spacewalks, advancing capabilities needed for future lunar missions. Tragically, White died less than 2 years later in the Apollo 1 fire during a launch pad test, along with astronauts Gus Grissom and Roger Chaffee. The technology for spacewalks evolved rapidly through the 1960s and 70s. Early spacesuits were bulky and restrictive, limiting astronauts' movements and endurance. Engineers continuously improved designs, increasing mobility, adding better life support systems, and enhancing safety features. By the time of the Apollo program, astronauts could work outside their spacecraft for hours, performing complex tasks on the lunar surface. Later designs for space shuttle missions allowed even longer EVAs with improved comfort and capability. Modern spacesuits on the International Space Station can support astronauts for 8 hours or more. During complex repairs and construction tasks outside the station. The most dramatic spacewalk occurred on February 7, 1984, when astronaut Bruce McCandless performed the first untethered spacewalk, using the Manned Maneuvering Unit, or MMU. This nitrogen-propelled backpack allowed McCandless to fly freely in space, without any connection to his spacecraft. He ventured 320 feet from Space Shuttle Challenger, becoming a human satellite orbiting Earth independently. The MMU represented the culmination of decades of engineering and training. The device weighed 340 pounds on Earth, but was weightless in orbit. It contained 24 small thrusters arranged to provide movement in any direction. McCandless controlled it with joystick-like hand controllers, requiring precise touch and spatial awareness. The successful flight proved humans could work independently in space. Floating here in orbit, you share the same view these pioneers experienced. Earth curves below, blue and white and green, slowly rotating as you complete your 90-minute circuit. Continents drift past. Africa with its vast deserts, Asia with its towering mountains, the Americas stretching from pole to pole. Oceans cover most of the planet, reflecting sunlight. The experience of seeing Earth from orbit profoundly affects most astronauts. Many report a psychological shift called the overview effect, a cognitive transformation that occurs when viewing Earth as a whole from space. Borders between nations, invisible from orbit, fade in importance compared to the obvious unity of our planet's interconnected systems. The atmosphere appears as a thin, vulnerable layer protecting all life. Soviet cosmonaut Yuri Gagarin, who flew in 1974, described Earth as looking like a small, fragile ball hanging in space. American astronaut Ron Garan, who spent time aboard the International Space Station, said, "When we look down at the Earth from space, we see this amazing, indescribably beautiful planet. It looks like a living, breathing organism." The overview effect has inspired environmental movements and international cooperation. Photographs taken by astronauts, especially the famous blue marble image captured by Apollo 17 crew in 1972, helped spark global environmental awareness. Seeing Earth as a unified system without borders made abstract concepts like atmosphere and biosphere tangible and real. The image became a symbol for environmental protection movements worldwide. As you continue floating peacefully, you become part of this legacy of human exploration. Every astronaut and cosmonaut who came before you contributed to the knowledge and technology that makes your journey possible. Soviet engineers developed life support systems and orbital mechanics. American engineers created spacecraft capable of reaching the moon. International cooperation built the space station, where crews from many nations work together. The International Space Station orbits about 250 miles above Earth, taking 92 minutes to complete one circuit, slightly longer than your orbit due to higher altitude. The station has been continuously inhabited since November 2nd, 2000, with crews rotating every 6 months. Astronauts from 19 countries have lived aboard, conducting thousands of scientific experiments. Life aboard the station has taught us much about long-duration spaceflight. Astronauts adapt to weightlessness, learning to float efficiently through modules. They exercise 2 hours daily to prevent muscle and bone loss that occurs without gravity. They eat specially prepared foods, some fresh, some freeze-dried, drinking water recycled from humidity and urine with remarkable efficiency. Some astronauts spend extended periods in space, accumulating months or even years in orbit across multiple missions. Russian cosmonaut Gennady Padalka holds the record for most cumulative time in space, 879 days across 5 missions. Astronaut Peggy Whitson holds the American record, 665 days total, becoming the oldest woman in space at age 57. Women have made tremendous contributions to space exploration, despite facing barriers in early programs. After Valentina Tereshkova's flight in 1963, no other woman flew in space until Soviet cosmonaut Svetlana Savitskaya in 1982. American Sally Ride became the first American woman in space in 1983 aboard Space Shuttle Challenger. Since then, women have served as mission commanders and spacewalkers. L. Astronauts from many nations have contributed to space exploration, expanding it beyond the Cold War competition between superpowers. The first international crew flew aboard Soyuz in 1975, when American and Soviet spacecraft docked in orbit, symbolically ending the space race. Since then, astronauts from Canada, Japan, Europe, China, India, and many other nations have flown, creating a truly global spacefaring community. Your breathing has naturally slowed, synchronized with the peaceful rhythm of orbit. Each breath connects you to the recycled air that sustains you. Oxygen extracted from water, hydrogen vented to space, carbon dioxide scrubbed by chemical filters. These systems descended from designs proven by early pioneers, who tested life support in primitive capsules. Every breath you take honors their contributions. Outside your window, Earth continues its eternal rotation. Day transitions to night every 45 minutes as your orbit carries you from sunlight to shadow. The Terminator line, the boundary between day and night, sweeps across continents, bringing sunrise to some regions, sunset to others. From your vantage point, you watch this daily cycle accelerated. As darkness envelops your spacecraft, stars emerge with brilliant clarity. No atmospheric distortion blurs their light, which has traveled for years or centuries to reach your eyes. Constellations familiar from Earth appear unchanged, their patterns stable across human timescales. The Milky Way stretches across the sky, a river of light composed of billions of distant suns. The moon hangs in the distance, its surface grey and cratered, clearly visible without atmospheric haze. 12 humans have walked on that surface between 1969 and 1972, the only humans to stand on another world. Their footprints remain preserved in lunar dust, undisturbed by wind or rain, which do not exist there. Mars appears as a bright red dot in the night sky, a world humans hope to visit within coming decades. Planning for Mars missions builds on lessons learned from orbital spaceflight. Astronauts will spend months traveling to Mars and back, requiring life support systems even more reliable than those used in Earth orbit. Yet the dream of standing on another planet drives space agencies forward. Floating peacefully, you become meditation in motion. Your body completely relaxed, every muscle released from tension. Weightlessness provides perfect support. No pressure points, no discomfort. Your breathing barely perceptible. Gentle inhale, gentle exhale. Your heartbeat slow and steady, pumping blood that circulates effortlessly without fighting gravity. The pioneers who came before you understood this peace. Despite the danger and uncertainty, they found moments of transcendent beauty. Gagarin spoke of Earth's fragile beauty. Glenn described his fireflies. Leonov recalled the wonder of his spacewalk. Each astronaut who followed added their observations to humanity's collective understanding. They gifted us perspective, showing Earth as a unified whole. Merci. Time moves differently in orbit. Clocks measure minutes and hours, but the rapid day-night cycle disrupts circadian rhythms. Your body, unsure whether to sleep or wake, adapts gradually to this new temporal environment. Eventually, you surrender to the rhythm, accepting that time is relative. that dawn and dusk have no fixed meaning here. Earth rotates below, continents drifting past in endless procession. Africa with its vast deserts and dense rainforests. Europe with its intricate coastlines and ancient mountains. Asia stretching from frozen tundra to tropical islands. The Americas extending from Arctic ice to Antarctic shores. Australia isolated in its ocean surrounding. Each continent tells billions of years of geological history. Oceans cover 70% of Earth's surface, containing 97% of its water. The Pacific Ocean alone, larger than all land masses combined, stretches halfway around the planet. These waters regulate global climate, absorbing heat at the equator, transporting it toward poles through currents. Phytoplankton produce over half of Earth's oxygen through photosynthesis. Your spacecraft maintains perfect velocity and altitude. Orbital mechanics, discovered by Newton and refined by countless physicists, govern your path. Gravity pulls you toward Earth, but your sideways velocity creates continuous falling around the planet rather than toward it. This delicate balance between gravitational attraction and inertial motion creates stable orbit. No propulsion needed. No energy expended. The sun provides all energy for your spacecraft. Solar panels converting photons into electricity. This same sunlight drives Earth's weather, creates winds, powers photosynthesis in plants. Every calorie of food energy, every gust of wind, every drop of rain originates with nuclear fusion occurring in the sun's core. Your mission here is simple. Exist peacefully in orbit. Observe Earth below. Honor those who came before. No complex tasks required. No challenges to overcome. Simply be present in this moment, floating weightlessly between worlds. Let your breathing slow even more. Barely perceptible. Let your thoughts quiet until only awareness remains. Now, the pioneers would recognize this feeling. Beyond the technical challenges and physical discomfort, they found moments of pure transcendence. Floating free above Earth, unburdened by weight and worry, experiencing existence from a perspective few humans ever know. These moments sustained them through difficulties and dangers, reminding them why exploration matters. Continents continue their drift below. Slowly, imperceptibly, the patterns of light and shadow shift. Clouds form and dissipate, following atmospheric currents. Rivers flow toward seas. Ice advances and retreats with seasons. Life continues unaware of your passage overhead. Billions of people wake, work, sleep, repeat daily rhythms. Your body temperature perfectly regulated by spacecraft systems. Your oxygen supply constantly replenished. Your water recycled and purified. Every need anticipated and met by technology refined through decades of experience. You need do nothing but exist, letting systems sustain you. This complete dependence on technology mirrors early pioneers who trusted their lives to experimental equipment. The aurora appears below. Shimmering curtains of green and red light, dancing across polar regions. Charged particles from the solar wind collide with atmospheric molecules, creating this ethereal display. Ancient peoples saw aurora as omens or spirits, unaware of their electromagnetic origin. Satellites drift in nearby orbits, some visible as bright dots moving against the star field. Thousands of artificial objects circle Earth, serving countless purposes: communication, navigation, weather monitoring, Earth observation, scientific research. These machines expand human capability. Space debris also orbits Earth. Remnants of past missions and satellite collisions. Tiny paint flakes, metal fragments, spent rocket stages circle at tremendous speeds. Space agencies track larger debris, warning satellites and the International Space Station of potential collision. Despite challenges and concerns, the view from orbit inspires optimism. Seeing Earth as a unified whole makes human conflict seem absurd. The atmosphere that sustains us recognizes no borders. Ocean currents flow without regard for national jurisdiction. Weather systems cross continents, affecting all regions equally. Your breathing now barely perceptible. Slow, gentle, peaceful. Your heartbeat steady and calm. Your mind quiet. Thoughts drifting like clouds across consciousness. You float in perfect stillness, despite traveling at tremendous velocity. This paradox of motion and rest characterizes orbital flight. Time to rest now, space traveler. You have learned about those who came before. You have understood the atmospheric layers protecting Earth. You have observed the overview effect, understanding how space transforms perspective. These lessons will remain with you, even as consciousness fades into sleep. The pioneers sleep too. Their missions complete. Their contributions recorded in history. Some have passed away. Their memories preserved by those who knew them. Others remain alive, sharing stories with new generations of explorers. All would recognize the peaceful floating you experience now. Earth turns below. Unchanging, yet ever-changing. The same planet Gagarin saw. The same view Glenn described. The same perspective that transforms all who experience it. You are part of this continuum of exploration and discovery. Your presence here matters. Not for any specific achievement. Stars shine steadily in the darkness. Distant suns burning for billions of years. Some already dead. Their light still traveling toward you. The universe, vast beyond comprehension, continues its eternal expansion. Galaxies drift apart, carried by forces we barely understand. Your orbit eternal as long as velocity maintains. Circling Earth endlessly. Day becoming night. Becoming day. The rhythm soothing. Predictable. Secure. You are held by invisible forces. Gravity and inertia balanced perfectly. Deep space surrounds you. Vast and empty, yet somehow comforting. The vacuum cannot harm you. Protected as you are by technology and knowledge. The cold cannot reach you. Temperature regulated precisely. The radiation cannot penetrate your shielding. pioneers watch over you in spirit. Their presence felt, if not seen. Gagarin's courage, Tereshkova's determination, Glenn's calm, Leonov's audacity. All these qualities contributed to your safety here. Their sacrifices purchased the knowledge keeping you alive. Weightlessness supports your sleeping body perfectly. No pressure points, no discomfort, no need to shift position. Muscles completely relaxed, bones unburdened. Blood flows easily without fighting gravity. Your breathing slow and deep. Dream now of continents drifting below. Dream of oceans reflecting starlight. Dream of mountains rising slowly over geological time. Dream of rivers carving canyons through ancient stone. Dream of forests covering landscapes. Dream of deserts stretching endlessly under eternal sun. Your mission continues even as you sleep. Orbit proceeds automatically, requiring no conscious attention. Systems monitor and adjust. Life support maintains perfect conditions. Temperature, pressure, oxygen, all regulated precisely. The cosmos cradles you gently. Space, infinite and eternal, holds you safely. Time loses meaning in sleep. Minutes and hours blend together. You drift in dreams, unaware of passing time. Floating peacefully in the dark, held by gravity, sustained by technology, protected by knowledge, honored by pioneers, connected to Earth, part of the cosmos. Complete and whole. Nothing lacking. Nothing needed. Perfect peace. Perfect rest. Sleep now. Deeply. Peacefully. among the stars, forever safe, eternal rest. Sleep peacefully, space traveler. The pioneers came before you. You honor them through peaceful rest. Sleep deeply now. Dream of Earth. Dream of space. Dream of unity. Complete rest now. Perfect peace. Among the stars, forever. Breathing barely perceptible. Heart beating slowly. Complete relaxation. Weightless sleep. Orbital peace. Earth turns below. You rest above, safe and still. Floating gently in cosmic embrace. Sleep now. Deep rest. Peaceful dreams. The atmosphere protects. Gravity holds. Technology sustains. You are safe. Sleep deeply. Among pioneers, their legacy surrounds you. rest peacefully in their path. Honoring their courage through peaceful sleep. Orbital meditation. Consciousness fading. Into dreams. Perfect rest. Complete peace. Forever floating. Forever safe. Sleep now, traveler. Rest deeply. Dream peacefully. among the stars. Earth cradles you. Space embraces you. Sleep eternally. In perfect peace, drifting peacefully. Among infinite stars, part of eternal dance. Of the cosmos. Earth rotates slowly. Displaying its beauty. In changing panoramas. The moon hangs distant and serene. floating here, between Earth and infinity. Your breathing grows. Even slower, even more peaceful. Carried by cosmic rhythms, where time moves differently. You shut it. Where rest comes naturally. Dreams and reality merge. The universe cradles you. In perfect safety. infinite peace. Rest now. Space traveler. Let cosmic rhythms carry you deeper into peaceful sleep. The stars keep watch over your dreams. Earth continues its eternal dance. Sleep peacefully among the infinite stars. forever drifting, forever resting. In cosmic peace, sleep now. Rest. And sleep.